Hello, this is Lorraine Jameson, and this is quiz number 4. So the first question, it gave you a differential equation, and you had to use Euler's method to solve for y of 1.2. And so in order to do this, I just set up the table that I typically use. And so you have your x value and your y value, and then delta y is the change in y from the initial y, is equal to dy dx times delta x, where delta x is equal to the step size. So in this case, dy dx is equal to x plus y squared. So you just plug in your x and your y. 0 plus 0 squared times 0.1 is equal to 0. And so you just you add this 0 with whatever the y value is here, which is 0 plus 0 equals 0. So your next coordinate is 0.1 comma 0. So you just plug that into this equation again. 0.1 plus 0 squared times 0.1 is equal to 0.01. And then you add 0.01 and 0 to get your next y value, which is 0.01. And then your final value for y of 0.2 is equal to 0.01. And so that is the answer to problem 1. Problem number 2, the population of bacteria in a culture grow at a rate proportional to the number of bacteria present at time t. Write a differential equation for this phenomena. So here on the left side of the page, I have set up the differential equation, which is dp dt is equal to kp. And so I just solve the equation. dp is equal to kp dt, and then I divided both sides by p. To get 1 over p dp is equal to k dt, and then I took the integral of both sides to get ln p is equal to kt plus c, and then I e'd both sides to get p is equal to e to the kt plus c. Using the rules of exponentials, you can separate them, so p equals e to the kt times e to the c. And then finally, p equals p naught e to the kt, where e to the c is equal to p naught. And so that was the first step to this problem. The second step to this problem gave you population values. And so the question was how many people were present at p of 0. And so to solve this, I just plugged in the equations. P naught e to the 3k is equal to 400. P naught e to the 10k is equal to 2000. And then as there's a P naught in both values, I was able to isolate it and then make an equation. So we have 400 e to the 10k is equal to 2000 e to the 3k. I'm just going to move my face over here so you can see the screen. And then, so you just divide both sides by the respective values. So 0.2 is equal to e to the 3k over e to the 10k. And so this, in order to simplify it, I just did that in my head, where it's 1 over 2 is equal to e to the 7k. And so ln 5 is equal, 5 is equal to e to the 7k, and then I took the natural log of both sides to get the k value, which is 0.2299. I think that's 19. And then after you have your k value, you can just plug that back in with both of these values to check your answer. So I used 400 at time 3 hours. So 400 is equal to p naught e to the 3k. And then using that, you can just divide 400 by e to the 3k to get your p naught, which is 200.67. Rounded to the nearest bacteria is 201 bacteria being the initial. And then it's not pictured here, but I cross-checked the answer with 2010 hours also. Thank you very much.